Steady-state AC circuit analysis using the TI-89 calculator. Notice the variables. These are impedance variables, A, B, and C. These are voltage variables, D, E, F, and G. And one current variable, I. Voltage polarities are consistent with current direction. This is a voltage rise in the direction of the current, a voltage drop, a voltage drop, and a voltage drop. Calculator is in the radian and polar modes. Enter the three impedances into these calculator variables. Given one voltage source stored into memory D, calculate the current and store into memory I. That's letter I after letter H. Calculate all three voltages and store into memories E, F, and G. Confirm voltages using Kirchhoff's voltage law. AC power or complex power. First, review DC power. Current times voltage, current squared times resistance, voltage squared divided by resistance, all in watts. Complex power is a complex number. Volt amps, watts, and volts amps reactive or VARs. The power triangle looks like this if Q is positive. Looks like this if Q is negative. S is a complex number with a real part and an imaginary part that can be positive or negative. AC power can be calculated three ways. The star means complex conjugate. Two is due to the phasor definition. This phasor definition shows the complex number where B is in radians. It represents that sinusoid. AC power can be calculated three ways: as a function of current and voltage, as a function of current and impedance, as a function of voltage and impedance. These three calculator functions will facilitate calculation. Complex power. This is the power delivered to the resistor, and the power delivered to the capacitor, and the power delivered to the inductor, and the power supplied by the source. Calculate all four of these complex powers, which is easy because our calculator already has all these values. Source power can be calculated. H is I star V divided by 2. The calculator function can be used to show the power P and the VARs Q. The other AC powers can be calculated in a similar way. And we can confirm the power balances for the entire circuit. If we'll use the calculator this way, we can avoid writing lots of complex numbers unnecessarily.